So I gave you guys the definitions on your handout already. When you have a line, the symbol for a line, it has A, B, 2 points, and then a line going across the top like this. Lines go on forever in both directions, so that's why there's arrows on both of that. And all it means is you have a point A, a point B, a line between them that keeps going. So you can draw the picture beside it if you want to kind of show yourself what I mean by a line. So it just goes forever in both directions when we're looking at a line. How is a line segment different?
It ends at the point.
And you can even kind of tell just from the shorthand, there's no arrows on that. So it starts at A and ends at B. Just that little piece. If I say ray AB, it will look like this. What that means, you'll notice in my little symbol here, the arrow extends over B. So it's saying it starts at A, goes through B, and then just keeps going. So a ray only goes in one direction. Now, when you put two rays together, you can form what's called an angle, which is more what we are focusing on in trigonometry. So an angle is two rays with a common endpoint. So you might draw this picture out to the side here. We're going to label some things in it. So here's a ray, here's a ray, and they're starting at the same endpoint. This makes an angle. When we have this, these two rays are the sides. So this is a side, and this is a side. This common point is called the vertex. Now what you probably haven't seen before is when we draw angles in here, we're going to put a little symbol in the middle. Looks like this. It's an arrow telling us which way our angle is turning. And that will determine the initial and terminal side. Initial means beginning. So if I'm looking at this, I would begin down here. So this would be my initial side. And then it spins and it ends up here. So this is the terminal side. So initial side is the beginning side, terminal side is the ending. What would happen if I drew the same type of angle, but I put the arrow like this?
Then that would be the terminal.
Yep, this would be the initial. And this would be the terminal. So that arrow just tells us which way we're starting and ending. And that actually determines if we have a positive or a negative angle measurement. We probably didn't ever do negative angles in geometry. And when you're measuring an angle with a protractor, you don't come up with negatives. But in general, if it's a positive angle, it's spinning counterclockwise. So it might just be from here up, or it could even be outside like this. Both of those would be considered positive. So it's counterclockwise. Negative angles spin clockwise. And again, there's a couple ways. You know, I did my counterclockwise going outside. You could have also had one that just went from here to here. That's still positive. If I had an angle that spun around the outside like this, that would still be negative. You're looking at direction, clockwise or counterclockwise. So basically, if it starts going up, that's your positive, down is your negative. All right, so next one, without looking at your paper, can you tell me, if I say an acute angle, what's that? Yeah, these are acute angles. The definition you've seen before is probably less than 90 degrees. Because we have negative now, we say acute is between 0 and 90. What's a right angle?
90 degrees exactly.
So an acute, something smaller than 90, a right angle forms. A lot of times you see the little box in the corner that tells you it is a perfect right angle. What's an obtuse angle?
Greater than
Because we are going to see angles bigger than what you've seen in the past, we're going to alter our definition a little bit. We're going to say it's between 90 and 180. Something like this would be obtuse. What would be a straight angle? A straight line, 180 degrees. Complement and supplement. What do you remember?
They add to 90, so it can be like 45, 45, 60, 30.
Good. And what do supplements add up to?
They add to 80.
Um,
Like 80 and 100.
So complementary, two or more angles, they add to 90. Supplementary, two or more angles that add to 180. Good trick, complementary starts with a C. C comes first in the alphabet, so that's the smaller one. So complements add to 90, supplements add to 180. Any questions so far? All right, so see if you can do this first example on your own. If your angle is 55 degrees, can you find the complement and supplement? Grab a calculator if you need to. So complements add to 90, so you just have to do 90 minus 55. Supplements add to 180, so 180 minus 55. Just kind of get in the habit of putting that degree symbol every time. It's going to be a few chapters, but eventually we're going to get another unit for measuring angles. And it doesn't have a unit symbol, so when we get to that chapter, if you put 55 but you don't put a degree symbol, we'll assume it's the other measure, and they're very different things. So we're going to try to break that habit now, get in the habit, always put a degree symbol when you're talking about degrees. All right, this one, if I want you to find the measure of each angle, what would we have to do here?
You have to put 2 r plus 3 r equals 90 degrees.
If I look at this, it has this box here, which means they're complements. They add up to 90 forms of right angles. So 2r plus 3r equals 90. So we get r to be 18. Okay, so I asked for the actual angles. So if you plug that back in, 2 times 18, so this angle is 36 degrees. 3 times 18,
50.
why don't you guys try this? see if you can figure out what you do. All right, so what'd you do on this one?
70 plus 60 equals 100.
Is this your personal one? Okay, so then my angles, you would have 7 times 20, so 140. And 2 degrees. Do you guys get that? For us, when we're talking about the measure of an angle, a lot of times we'll put a lowercase m for measure an angle, and then whatever the angle is named. So whether it's measure of angle A or measure of angle B. So when you see that little m, that means just give me the measure. I'm pretty sure it keeps turning off. Now one thing that, the next case that we're getting into is new for everybody. When you're measuring angles, you've always done it to the nearest degree, okay? Or you might have a decimal every now and then. But sometimes we need to be more precise than that if you go into surveying, you know, measuring parcels of land and things like that. If you ever look at a legal description of a piece of land, it doesn't say 21 degrees. It says 21 degrees, 49 minutes, 36 seconds. They use minutes and seconds to get more precise in their measurement. So we need to know how to work with minutes and seconds and go back and forth between that and decimal form. So that's our next focus. It works a lot like time. So basically just replace hours with degrees. So an hour is like a degree. So 60 minutes would equal 1 degree. For minutes, we use a single tick mark. So 60 minutes is equal to 1 degree. 60 seconds is going to be equal to 1 minute. So we have our circle for degrees. 1 tick mark means minutes. 2 tick marks means seconds. And we can do calculations with these, just like we would with decimals or anything else. So we can add, subtract. We're not going to multiply or divide, but we will add and subtract with these. So let's try a couple. It's going to kind of take you back to your elementary days. When you added with decimals, what did they make you do? Did you leave them written side by side? Or did you stack them up? Did you stack them up and you lined up your decimal point, right? So we're going to stack them up and we're going to line up our degrees and our minutes. So when we add these, we add like things. So we add the minutes together. So what's 35 plus 52? 87. So we get 87 minutes. And then we add our degrees together. So 28 plus 63. So we have 91 degrees, 87 minutes. Okay. Now if you're talking to your friend and they ask when you're going to show up, will you say, oh, I'll be there in 2 hours and 87 minutes? No. What would you do? Since 87 is bigger than 60, you would convert that into an hour, right? Yes. So when you're looking at this, we could take away 60 minutes and add it to our degrees. So I would bump my degree up to 92 degrees, and then if you take away 60, 87 minus 60 is 27 minutes. So we'll say 92 degrees, 27 minutes. Does everyone understand where I got that? And the only time you have to do that is if your minutes or your seconds is bigger than 60. Then you'll just convert them over. All right, so subtraction works kind of the same. We have 180 degrees minus. We want to line up the degrees, line up the minutes. Okay, my 180, I didn't have any minutes, so I'm going to write this as 180 degrees, 0 minutes. When you go to subtract, we have to subtract our minutes first. Can you do 0 minus 29? No. So what you did way back when was borrowed, right? So if I take away a degree, it's 179 degrees. When you bring that over, how many minutes is that 1 degree?
60.
So now I can do 60 minus 29. 179 minus 117.
62.
So I get 62 minutes, 31, or sorry, 62 degrees, 31 minutes. My minutes aren't bigger than 60, so that's my point. Why don't you guys try the next two on your own? Okay, so the first one, if we add our minutes, and then add our degrees, you get 72 degrees, 86 minutes.
But we gotta convert that.
Right.
So
You have to
we get 73
The second one, we don't have any minutes up here, so this is like 120 degrees, 0 minutes. So we have 119 degrees and 60 minutes. Your book, if they have single digits, they'll always put like 04, 03. You don't have to, I don't care. Just don't be surprised when you see that. So 60 minus 4 would be 56. 119 minus 101. So 18 degrees, 56 minutes. Did you guys get this? Okay. So let's talk about converting. Sometimes we'll have decimals, sometimes we'll have degrees, minutes, and seconds. And on your handout, I kind of stepped out how we can go back and forth between the two. If we want decimals, then we have to think of these in terms of fractions. Okay, we have the 105 degrees. 20 minutes. How many minutes are in a degree?
60.
So this is like 20 out of the 60. All right, seconds. Think about time for a second. How many seconds are in an hour? 3,600. 60 times 60. So for the seconds, we have to divide it by 3,600. So we're essentially changing each of these into degrees, so we set them up in fraction form. There's 60 minutes in a degree, 3,600 seconds in a degree, so we divide those, and then we just put the whole thing in our calculator. So I'm going to type in 105 plus 20 over 60 plus 32 over 3,600. I said nearest 1,000, so 3 decimal places, round up if needed. We're at 105.342 degrees. Okay. So when we have degrees, minutes, and seconds, we divide to get the decimal. When we have the decimal, what's the opposite of dividing? Multiplying. So we're going to multiply to get the whole thing. So the degree part doesn't change. We still are going to have 85 degrees. To get the minutes, we take the decimal part, so 0.263, and how many minutes are in a degree? So we multiply that by 60. And we get 15.78 minutes. So that means I have 15 total minutes. Now we want seconds. So we have 0.78 of a minute here. So we're going to use this decimal. Okay. But that's minutes. How many seconds are in a minute?
60.
So we're going to take the 0.78 times 60. So essentially you just multiply the decimal times 60 each time. And that gives me 46.8 seconds. We will round that to the nearest whole second, so that would round to 47 seconds. Did I lose anybody here? I'm gonna try a couple. There's one of each for you to try your conversions. So the first one, we have 74 degrees. We have 8 minutes, so there are 60 minutes in a degree, so we'll do 8 divided by 60. 14 seconds. There are 3,600 seconds in a degree, so we divide by 3,600. And you should get, I said nearest thousandths, so 3 decimal places, 74.137. And then put your degrees in. Is that one good?
I didn't do that, but I think I typed in my calculator.
Okay. I love that what you typed in. Oh, you have all the work. Alright, going the other way. So we're going to keep the 34 degrees. How do you get your minutes?
You take the 0.817 times 60. So you get 49.2.
And so in this, we just keep the 49 minutes.
Then you take 0.02 times 60 per seconds,
Good.
resulting in 1.2.
And round that to the nearest, so that's 1 second. If you put 0.1 seconds, that's fine as well. I don't care. All right. So far, so good? Let's stop there for today. So I'm going to put some problems up here because you've got some time to work. They are not due tomorrow. We'll finish the section tomorrow, but you can get started. It looks like a lot because I listed out every single problem, but you're ready for